To be honest, I don't know. I don't remember. But ads. To make money off of it, you need to be like 10,000. I definitely got 10,000 views. Okay, I don't expect it. People are not like, oh, I gotta go and check out that math lesson. No one does that. You guys are looking up like makeup tutorials and how to dress, fashion, Fortnite, oh, Twitch streams. I get it. I get it. Okay. So I'm recording this. I'm recording this lesson. I'll post this one with this in case you guys need to review. So we'll kind of get you caught up. For this one right here, we have sine, secant, tangent. The first step in doing all these is to do what? Convert. Convert to sine and cosine. So my sine here is going to remain the same. And again, I'm leaving out the x, which is just the angle. I'm going to add it at the end of it. Secant is what? Secant is here. Where's my secant? Secant, 1 over cosine. And then we're going to divide it out by tangent. Converting to tangent. Sine over cosine. And I guess I know we're supposed to put the x variable there, but I'm just leaving it out to the end. I like to reduce everything down. So we're going to get sine over cosine. Put that in my parentheses. Over sine over cosine. Now, a fraction divided by a fraction, how do we simplify this out? Multiply by its reciprocal. So we got to be able to multiply. So the bottom would be cosine over sine. We would also multiply the top by the same thing, right? Absolutely. The bottom's going to cancel. Okay. So cosine, cosine, sine, sine, these cancel out. It's just going to give me 1. And then what about the top? What happens to the top as well? We have sine cancels out with sine. Cosine cancels out with cosine. We're left with 1 or just 1. So this is another nice case of simplifying a expression. Okay. Good stuff? Okay. Whoa. Good? Here we go. Another one. Copy this one down. For those that are getting this, I suggest you try to get a little bit step in front of me. Try to find this out before I figure it out. I was going to verify and test you whether you get this right or wrong. I'm still covering the basics of these. I don't want to get too far ahead. I'm going to give you some homework that deals with simplifying the expressions. And I'm looking for the work for this, right? I'm looking for the work. That's going to be what I'm looking for. So copy that down. Input is absent. Where to here? D-Rock. D-Rock. Here we go. First step is do what? Convert. Convert T, vert T. Cosine. What about secant? Will be converted to what? Secant is right here. I'm looking at my identity is 1 over cosine. Minus, and then cosine is going to be by itself. We don't need to convert that one. What do you think I got to do here? What do you want to do? Distribute? You can find the common denominator or you can distribute. There's 2 ways of doing it. I'm going to show you both. This is the cases in which you can find both ways. Some people like doing it one way. Some people like doing it the other. This is the distributor way. This is the finding the common denominator way. So common denominator and then distribute with this. Okay. The distributor way works the same thing, right? I'm going to distribute my cosine to every single term on the inside of here. So I'm going to get cosine over cosine minus, what's cosine times cosine? Cosine squared. What does this reduce down to? 1 minus cosine squared. Here we would stop here and go, what do I look at? I'm looking at these identities and going 1 plus something, 1 minus something squared. I'm looking at my Pythagorean identities. And you guys have them on your guys' paper. We should know it's going to be sine squared. So sine squared would be my answer. To write it out fully, we're going to throw in that theta for my answer. Okay, that's technically my answer. Now that's the distributive way. These are what I'm telling you. There's multiple ways of doing some of these types of problems. Now finding the common denominator, what we would do cosine. It's a little bit longer, but again, it just works out nicely. To find the common denominator, we do 1 over cosine minus cosine over cosine squared. Again, I'm jumping ahead for you guys. We would simplify this out. So we would get 1 minus cosine squared over cosine. Then what happens to those cosines? They cancel, and we're like left with 1 minus cosine. And then this becomes sine squared, which is the same thing. So both ways work out. There's multiple ways of solving this. And when we get to the more complicated types of problems, it's going to get more complicated. It always gets worse before it gets better. Always gets worse before it gets better. Okay? You try to separate these types of problems here. Good stuff? Another one? Cool. Cool beans, man. Copy. First step, convert 1 plus cosine. Liking some of you guys trying to get ahead of me. Showing you guys want to practice this, which is awesome. Cosecant. 1 over sine. This involves looking at the cosecant reciprocal identity minus cotangent, which is cosine over sine. Yes. Because we want to change them into sines and cosines. If it's already in cosine, we keep it. We don't need to move it. It's the same thing with sine. If they're already in the form that we're looking for, we don't need to convert them back. Most identities will be able to convert into sine or cosine. Right? If you're looking at the reciprocal identities, they all have some relation to sine or cosine. Okay, even the Pythagorean identities, we can use sine and cosine. Tangent identities, sine and cosine. Even in our identities, sine and cosine. So they always involve using sine or cosine. So we convert them, we can have more tools to use in order to solve out. Does that kind of make, yeah, so that we want to be able to do that. Hold off on the reciprocal identities for tangent and cotangent. Only use, because we're converting to sine and cosine. So it only makes sense to put it using the tangent identities rather than the reciprocal identities, because we still have to convert them. Right? It doesn't make sense to have to convert it twice. Okay. What do we do here? We'll see. Reduce? You'll see. We can convert this into one fraction. We want to be able to make as small as possible. They contain the same denominator, sine and sine. So we're just going to get 1 minus cosine over, we're just reducing. We're finding a common denominator. I'm going to go ahead and write them together underneath the same fraction, same rational. Radical, rational, radical, rational. What do I do here? Oral. First, outer, inner, and last. Still over sine. Now from here, kind of running out of room, you see my little plus sign right here is going to be my sign right here. What happens when I reduce? What do I get? What happens to cosine and sine? Yeah. Thank you. You know what I meant. 1 minus cosine squared over sine. Now at this point, we reduce it down as much as we can. I'm seeing something here that I like. The 1 minus cosine, 1 plus cosine, it doesn't matter. We're trying to look for the identity. What identities that match up with? Sine squared, man. Over sine, this reduces down to what? Almost? Ah. Okay. Yeah, for sure. I got you. Okay? We okay? First day back, it's like, ooh, it jumps right into it. I try teaching this the slowest way I possibly can, just because this is a really good, this is my favorite chapter, but it's the one the kids hate the most. Okay, here we go. Another one. Again, if it's sine and cosine already, 1 minus cosine squared, there's nothing else we can really do. We don't need to split it up. It's not asking us to FOIL. It's not asking us to make it into a single fraction. It's already a single fraction. So we need to kind of work with this. Okay. Our top is going to remain the same, but I'm noticing on the bottom I have an identity I can use. That being what? Sine squared. This is sine squared from using the identities. Then what happens to our terms here? Cancels and cancels out one of the signs here, so I'm left with cosine over sine, which is what? Cotangent. There you go. Cotangent of x. Good stuff? The more we do, the more confident you feel a little bit. It's always that way, right? And then once I'm like, do this homework, you're like, I don't know how to do this. Okay. Again, keep on pushing forward. If you get this, keep on nipping away at it. Keep on going a little bit more forward than me. Okay. Miss is a good teacher. She just teaches differently. She goes fast. You can't go fast with this. You can't go fast. Each teacher has their own style of teaching. You guys like. Okay. We'll get you started. First step here. Convert cotangent cosecant one over sine. Do I need to convert sine? No.
Oh, I got it right.
I'm going to put it 1 over 1 like that. I want to be able to reduce, again, fractions from fractions, denominators to denominators. I'm going to do the one on the bottom here. I'm going to show the work for this. This will be sine. 1 times sine is sine. The common denominator is sine. So the top one's going to be 1. The second one will be sine squared. Therefore, if we reduce this down, right? So that's going to go here. I don't know. I don't think it's. I don't know. Not sure. Not sure yet. Let me get there. You're jumping ahead. No. What can you do here? If you're already starting to see it. If you're not sure yet, you can simplify that out further. But can we convert that 1 minus sine squared? Because you're starting to identify, like, I see the reciprocals now. That's where you want to get with this. So what is 1 minus sine squared? Cosine squared. So I'm just going to convert that to cosine squared. So I'm happy you guys are starting to see that. That's awesome. Okay. And then what do we do here? Multiply by the reciprocal. So I'm going to take a leap from here just because I'm running out of room. You should get cosine over sine, which is the top. But in the bottom reciprocal, which should have been sine over cosine squared. Then what happens? Sine cancels, cosine with the cosine give me 1 over cosine, or more practice. It's like, you probably, did you make a mistake on the operations? Yeah. Again, just more practice, right? More practice will get you there. Yeah, okay. Yeah. You'll catch on, right? You know, surprisingly, the more mistakes you make, the more you know you're not going to make that mistake again. So that's, to me, I like this mistake. So it's really okay. Just don't do them on a test, right? Don't do them on a test. Don't do them on a test. Okay. Are we good? Yeah, just do it. Copied on this one. And I can't remember what time do we get out of here? We get out of here. What time you got? 22? Okay, 10 minutes. So we have enough for like one more. We'll do one more. This will end it. We'll end it here. We'll end it here. This one's a little bit more complicated. Here we go. Cosecant, what is it? Secant. I'm going to reduce some of the fractions before I add. Shh. Almost done, guys. Multiplying by its reciprocal, I'm going to get multiply by the reciprocal. Identity comes out. Look at your Pythagorean identity. Right here. We're going to have this exact thing. For what? All I'm doing is oh my God. That's beautiful. It's more of a puzzle than that. Not for these ones. No. Because look, absolutely, you're absolutely right. In the event that we have something like this, so why don't we find a common denominator for this? In this case, we converted these first. But what I want to be able to do first is simplify out those two before I find a common denominator. So we're going to reduce those fractions first before it. Now, if it could have given us sine plus cosine, right? For the denominators of these, like if it could have given us something like this, right? Let's say if that was the case, then we would find the common denominator. But since these reduced down already, they get rid of the fractions. We don't have to do that step. Okay. Those are my earrings. I left them.
No, I did. I know you got those. They were mine.
Yes.